Hello students, in this video class we are going to discuss a program related with method recursion, and the question is write a Java program which will take an integer number as input and convert it to its hexadecimal equivalent. Hexadecimal equivalent. Hexadecimal equivalent. Use the method recursion technique. Use the method recursion technique. Use the method recursion technique. Okay. Write a Java program which will take an integer number as input and convert it to its hexadecimal equivalent. Okay. Use the method recursion technique. What is method recursion? Method recursion means if the method will call itself, the process will be called as method recursion. Okay. Now listen. If we have the number 3234, so I will show you the way we were finding in decimal to binary, then the same decimal to octal, and then the same number from decimal to hexadecimal. Now, what is the difference between the three processes? I will tell. Okay, just keep patience. So decimal to binary. So what was the number 3234? Okay, 3234, whose base is 10. It means that the number belongs to decimal number system is equal to question mark base 2. That means its binary equivalent is required. So 3234, we have to divide it by 2. 2 ones are 2, 2 6 are 12, 2 ones are 2, 2 sevens are 14. So what is the remainder? Remainder is 0. Okay. 2 8s are 16, 0. 2 8s are 16, remainder 1. 2 4s are 8, 0. 2 4s are 8, remainder 0. 2 2s are 4, 0. 2 2s are 4, remainder 0. 2 1s are 2, 0. 2 1s are 2, remainder 0. Okay, 2 5s are 10, 0, remainder 1. Then 2 25s are 50, remainder 0. 2 12s are 24, remainder 1. 2 6s are 12, remainder 0. 2 3s are 6, remainder 0. 2 1s are 2, remainder 1. Now, if we go from bottom to top, so this is the binary equivalent of 3234. 3234, okay, base 10 is equal to this number. Which number? This number, okay. 1 1 0 0 1 0 1 1 0 1, okay, 0 0 0 and then 1 0, okay, 0 0 1 0 base 2, okay, 1 1 0 0 1 0 1 0 0 1 0. Clear? Now here, okay, let me show you the conversion of a decimal number to octal, to its octal equivalent. Now the same number, if 3234 base 10 means the number belongs to decimal number system, is equal to question mark base 2. So 3234, in case of binary, we were dividing it by 2. Yes or no? So in case of octal, we need to divide it by 8. Sorry, here the base should be 8. Okay. So 3234 divided by 8. 8 4s are 32. 3. So it will be 0. Then 8 4s are 32. 34 minus 32, remainder is 2. Okay. 8 5s are 40. Then 0, remainder is 4. Okay. 8 6 are 48. Remainder is 2. Okay. Now, here we need to stop. Why? because we have got 6 which is less than 8. So if we are getting any value which is less than 8, then there we need to stop. There we need to stop. Now we need to go from bottom to top. So we can write 3234 base 10 is equal to 6242. 6242 whose base is 8. That is the octal equivalent of 3234 is 6242. Is 6242. Clear? Okay. Yes. Now listen. If I have to convert the same decimal number to hexadecimal, now listen, let me show you one thing to you. See, in this case, initially the value of n is 3234. Then the value of n becomes what? 1617. Then the value of n becomes 808. Then the value of n becomes 404. Then the value of n becomes 202. Then the value of n becomes 101. Then the value of n becomes 50. Then the value of n becomes 25. Then the value of n becomes 12. Then the value of n becomes 6. Then the value of n becomes 3. And finally, the value of n becomes 1. So here, okay, here the base case was, what was the base case? Here the base case was if n is equal to 1, the method has to return what? The method has to return 1. Why? Because the binary equivalent of 1 is 1 only. So this was the base case. Okay, this was the base case. Okay, when we were using the method recursion technique. Now in decimal to octal, initially the value of n was 3234. Then the value of n becomes 404. Then the value of n becomes 50. And then the value of n becomes 6. Now here we need to stop. That means if the value of n is becoming anything which is less than 8, the process should stop. So here we can say the base case was if n is less than 8. Because if here 8 was there, so 8 ones are 8. Okay, we had to divide them. But here 6 is there, which is less than 8, so we were not dividing. Okay, so if n is less than 8, so we need to return what? We were returning that particular value of n concatenated with empty string to make that value string value, because the return type of that method was string. So this is the base case. Okay, this was the base case in case of decimal to octal. Okay, base case. Here also this is the base case. Okay, base case, or you can call terminating case. Now let me show you from decimal to hexadecimal. Now the same number, suppose the same number 3234 whose base is 10 is equal to question mark whose base is 16, whose base is 16. Okay, that means the base is 10 means the number belongs to decimal number system. And if the base is 16, that means the number belongs to hexadecimal number system. So here question mark is given, it means it is asking you to find the hexadecimal equivalent of this number 3234. Now in case of binary, we were dividing it by 2. In case of octal, we were dividing it by 8. So common sense says that here we will have to divide it by 16, yes or no? So 3234. Okay, 3234. Now listen, we will divide it by 16. Now 16 2s are 32. So 3 is a fresh number, so 0, 34. 16 2s are 32. What is the remainder? The remainder is 2. The remainder is 2. Now again divide this value 202 by 16. So 16 1s are 16, 42. 16 4s are 64. 16 twos are 32, 16 threes are 48. So 16 twos are 32. So 16 ones are 16. So remainder 4, 42. 16 twos are 32, remainder 10. Remainder 10. Yes or no? When you will divide 202 by 16, you will get 10 as the remainder and 12 as the quotient. Okay. Then now here we need to stop. Okay. Here we need to stop. Why? Because the value is less than 16. Okay. So here we can say initially the value of n is 3234. Then the value of n becomes 202. Then the value of n becomes 12. Clear? Now this is the base case. What is the base case? If the value of n is becoming anything which is less than 16, then we need to stop there. Why? Because assume if here 16 was there, we would have divided it by 16. But here the value 12 is there. Okay, so we need to stop because it is less than 16. So what is the, just give me 1 minute. So what is the hexadecimal equivalent of 3234? So we can say 3234, okay, base 10 is equal to, we need to write 12 separately. We need to write 10 separately because this is the remainder. You cannot write 1, 2, okay, 1, 2 together. Okay, we need to write 1, 2 together, then 10, 1, 0 together, and then 2. So in hexadecimal, okay, 2 will be written as 2, 10 will be written as capital A or small a, because in hexadecimal number system, the digits are 0 to 9 and capital A to capital F, or you can say what? Small a to small f. Clear? So what is 12? If 10 is symbolized by capital A, so 12 means C. That is equal to capital C, capital A to base 16. So what is the hexadecimal equivalent of 3234? CA to base 16. Clear? So here what is the base case? The question arises, what is the base case here? See here, the base case is if n is less than 16. Now, what to return? Okay, what to return? I will discuss. Okay, don't worry, this part I will discuss. If n is less than 16, we cannot return 12 because 12 is represented by capital C. Okay, this 10 is represented by capital A. Now, in order to do that, okay, what has to be done? Listen. Listen. See. Let me define that method. Public static string get hexadecimal. Get hexadecimal int n. Okay, get hexadecimal int n. Okay. Now listen, what is the value of n? Assume 3234. But what is the base case? The base case is if n value is less than 16. This is the base case. Now we do not know whether the value of n here, we do not know whether the value of n is 1 or it is 2 or it is 3 or it is dot 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 9 or it is capital A or capital B or capital C. When I say capital A means what? So let me not write capital A, or 10, okay, or 11, or 12, or 13, or 14, or 15. Because if the value of n is from 1 to 9, we need to return what? Directly that value of n in string format. But if the value of n is 10 or 11 or 12 or 13 or 14 or 15, we need to return capital A in place of 10. We need to return capital B if n value is 11. We need to return capital C if n's value is 12. We need to return capital D if n value is 13, and we need to return capital E if the value of n is 14, and we need to return capital F if the value of n is 15. That is the reason why under the base case we need to apply conditions. See, the condition is, see, the main condition is n. If n is less than 16, this is the base case. Okay, but within the base case, we don't know whether n is 1 or 2 or 3 or up to 9 or 10 or 11, because we don't have to return 10. In place of 10, we need to return capital A. In place of 11, we need to return capital B. So here we will check if n is equal to 10. Okay. So the method will return capital A. The method will return capital A. Else if n is equal to 11, the method will return capital B. The method will return capital B. Else if n is equal to 12, the method has to return capital C. Okay. Else if n is equal to 13, the method has to return capital D. The method has to return capital D. Else if n is equal to 14, the method has to return capital E. The method has to return capital E. Okay. Else if n is equal to 15, that is the last digit of hexadecimal number system, return F in string format. Okay. Why in string format? Because the return type of the method is string only. Okay. Else, now in else part, see, n is less than 16, yes. Now here it is checking if it is not equal to 10, if it is not equal to 11, if it is not equal to 12, if it is not equal to 13, if it is not equal to 14, if it is not equal to 15, it means the value is a single digit number. That is from 1 to 9. In between 1 to 9 or from 1 to 9, any digit. So in such case, else part, we will return what? That particular value of n concatenated with empty string. Now, why am I concatenating this value of n with empty string? To make the value string, because the return type of this method is a string. Clear? So this is the base case. Okay, this is the base case. Clear? This is the difference. What is this? This is the base case, or you can say terminating case. Okay, terminating case, base case or terminating case. Clear? Now listen. Else. Okay, else. Yes. Else, what has to be returned? Now listen. See, if n value here, right side, if n is not less than 16, so this process continues. In the second step, how to get 202? When we divide 3234 by 16, we are getting 202. So we need to pass 3234 divided by 16. That is n divided by 16. Okay. And we need to concatenate the same value, or yes, the same value with what? The remainder, with the remainder. So we can say we need one more variable, remainder variable. Okay. Which variable? Remainder variable. So here, let me declare one variable, int remainder. Int remainder is equal to 0. Now in else part, okay, in else part, I need to calculate the remainder. So what is the remainder? The remainder is the value of n modulus 16. Now listen, see, initially if the value of n is 3234, so 3234, assume here the value of n is 3234, assume here the value of n is 3234, okay. Now 3234, is it less than 16? No. So the else part will be executed. Okay. So remainder is equal to n modulus 16. N modulus 16 means 16 2s are 32. Okay. 3, 0, 4. 16 2s are 32. Remainder 2. So how to get this 2? 3234 modulus 16. Can I say 3234 is n modulus 16? Okay, so remainder is equal to n modulus 16. Now here in this case the modulus value is 2. In this case the modulus value is 2, which is a single digit number. But sometimes a double digit comes in the remainder. Okay, for example, if this 202, okay, suppose if this 202 in the second step, okay, you can see the second step. In the second step, we are dividing 202 by 16. Now let me show it to you. Now, if I am dividing 202 by 16, so 16 ones are 16, right? What is the remainder? It is 4, 42. So 16 twos are 32, that is 10. Now how to get this 10? So 202 modulus 16. At that particular time, the value of n will be 202. So n modulus 16 means the same thing. So we can say if the remainder is 10, then what? Then capital A has to be concatenated. If the remainder is 11, then capital B has to be concatenated. With what? I will tell you. See, else part, return, okay. Now let me put the condition. Let me put the condition after calculating the remainder. Don't worry, I will explain everything. Just keep patience and listen. Yes, listen. So remainder is equal to n modulus 16. Remainder is equal to n modulus 16. Okay. See, here I will put condition if the remainder value, if the remainder value is equal to 10. So the method has to return, and here what I will do, I will call the get hexadecimal method, which is the recursive method. Get hexadecimal method, and here I will pass n divided by 16 concatenated with what? Concatenated with capital A. Why? Because the remainder is equal to 10. Clear? Now else if the remainder value is equal to 11. So in such case the method has to return, then call get hexadecimal n by 16 concatenation sign capital B. Concatenation sign capital B. Now else if remainder is equal to 12, return, call the get hexadecimal method, okay, pass n by 16 concatenated with capital C. Okay, else if remainder is equal to 13, return and call the get hexadecimal number. Get hexadecimal number, method n by 16 concatenated with D. Okay. Then else if remainder is equal to 14, return get hexadecimal. Return get hexadecimal n by 16 plus capital T. Okay. Else if remainder is equal to 15, so here only I will write, since there is no place, return the method get hexadecimal, okay, n by 16 and concatenate it with capital F, and in the else part I will return, see, in the else part I have calculated the remainder which will be obtained after dividing the value of n by 16. So if the value of n is 3234, what is the remainder? 2. Okay. So 2 is equal to 10? No. 2 is equal to 11? No. 2 is equal to 12? No. 2 is equal to 13? No. 2 is equal to 14? No. 2 is equal to 15? No. So in the else part, I will return what? Get hexadecimal method. Okay, here I will call the get hexadecimal method and pass n by 16 and concatenate what? Concatenate that particular remainder value. Okay, just the remainder, that is 2 will be concatenated. Clear? Okay, and here I will close the else part. Clear? And here let me close the method. Which method? Get hexadecimal method. Clear? So this case can be considered as what? Recursive case. Okay, from here to here, this case can be considered as the recursive case. Okay, now why this method is becoming lengthy? Because in hexadecimal number system, digits are from 0 to 9 and 10 is represented by capital A, 11 is represented by capital B, 12 is represented by capital C, 13 is represented by capital D, 14 is represented by capital E, and 15 is represented by capital F. Now you can see in this case, in the second step, 202, the value of n 202 is getting divided by 16, okay, and the remainder we are getting is 10. So it is equal to 10, yes. So in such case, A will be concatenated with the method call. So whatever value will be written by this get hexadecimal method, that value will be concatenated with capital A. This is the reason why this method is becoming lengthy. Clear? Now let me write this method and check whether the program is, or this coding is working fine or not. Create a class. Okay, give any name. Okay. Control A, backspace. Listen. import import java.util.scanner scanner public public class deciml decimal to hexadecimal decimal to hexadecimal public public static static void void main, okay, capital string string array space args control shift I scanner scanner scn equals to new scanner, okay, system.in system.out.println system.out.println enter an integer value, int n is equal to scanner object dot next int, okay, string what? Hexadecimal equivalent. He means hexadecimal equivalent is equal to what? Get hexadecimal, get hexadecimal, and here just pass the value of n. Okay, system.out.println, system.out.println, it is println, huh? System.out.println, the hexadecimal equivalent, hexadecimal equivalent of concatenation sign n is equal to concatenation sign he. He means hexadecimal equivalent. Okay. Now let me define the get hexadecimal method. Public public static static string string get hexadecimal int n. Okay, int n. Now what is the base case? The base case is if n value is less than 16, you need to return. But while returning, again, there are certain conditions. See, if the remainder value, okay, not remainder, if the value of n in such case, see, n is less than 16, means chances there, the value of n could be from 1 to 9, or chances there, the value of n could be from 10 to 15. If it is 10, we cannot return 10. We cannot return 10 because in hexadecimal number system, 10 is represented by capital A. That is the reason why here I need to put conditions such as if n is equal to 10, then the method has to return what? Then the method has to return capital A. Okay. Else, if n is equal to 11, return what? Return capital B. Okay, let me copy this line. Okay, B, C, D, E, F. Okay, so if n is equal to 12, if n is equal to 13, if n is equal to 14, if n is equal to 15, if n is equal to 16. So if it is 12, B, if it is 13, then the method has to return C. Okay, if it is 14, the method has to return B. If it is 15, the method has to return E. And if it is 16, not 16. 16 is not there. Okay, because it is less than 15. In hexadecimal number system, 16 is not there. So let me delete this. Yes. So if n is less than 16, we need to check whether it is 10. If it is 10, return A in string format. Why? Because the return type of the method is a string. Else, if n is equal to 12, we need to return B. If it is 13, return C. If it is 14, return D. If it is 15, return E. Else part. Else part means the value lies from 1 to 9. It is not a 2-digit value. That is, it is not 10, it is not 12, it is not 13, it is not 14, it is not 15. So it is a single digit number. So else we will return what? The n value, but in a string format. So we will concatenate empty string with it. Why? So that the value of n, which is of type int, becomes a string value, Okay. So what is this? This case is called as the base case. I mean, here the process ends. Here the process ends. Now, let me write the recursive case. Yes, let me write the recursive case. Yes. So in else part, now what I have to do? I have to calculate the remainder. You can see 3234. Is it less than 16? No. So I need to continue the process. So in this process, I need to call the same method by passing 202. How to get 202? 3234 divided by 16. That is n by 16. Okay. But this remainder value, okay, this remainder 2, this remainder 10, it has to be concatenated at the same time while calling the method. Okay. Now, see, the remainder which will be concatenated, okay, if it is 10, I mean, if it is a double digit number, if it is 10 or 11 or 12 or 13 or 14 or 15, then we cannot concatenate 10 with it. If it is 10, we need to concatenate A. If it is 11, we need to concatenate B. If it is 12, we need to concatenate C, and so on. Clear? That is the reason, listen, that is the reason we need to calculate the remainder here. Okay, we need to calculate the remainder. For that, we need to declare a variable with name remainder, R-E-M-I-N-D-R, remainder. Just initialize 0 since it is a local variable. Now here I will use the remainder. Remainder is equal to what? That particular value of n modulus 16. Okay, so that particular value of n will be divided by 16 and the remainder obtained will be initialized to remainder. Now here we can check. If the remainder value is equal to 10, the method has to return, then call the same method get hexadecimal. And here I will pass n divided by 2 concatenated with what? Concatenated with capital A. Why capital A? Because the remainder value is 10. Okay. Now, else if REMAINDR remainder is equal to 11 RETURN return get HEXADECIMAL get hexadecimal n by 2 concatenated with capital B. Okay, concatenated with capital B. Now let me copy this. Okay, A, B, C, D, E, F. Okay, listen. So if it is equal to 12, if it is equal to 13, if it is equal to 14, if it is equal to 15, okay. So here I need to concatenate capital C. Here I need to concatenate capital D. Here I need to concatenate capital E. Here I need to concatenate capital F. Okay. So why? Because see, if the remainder value is 10, we cannot concatenate 10 because in hexadecimal number system, 10 is represented by capital A or small a. Okay. Here I am using capital letters. Okay. You can use small letters also. If the remainder value is 11, 11 cannot be concatenated. In such case, capital B has to be concatenated. If the remainder value is 12, capital C has to be concatenated. If the remainder value is 13, capital D is concatenated. If remainder is 14, capital E is concatenated. If remainder is 15, capital F is concatenated. Now else part, just apply your mind. See, in the else part, what do I have to do? Listen, in the else part, what needs to be done? Think. Think. See, if the remainder value is not 10, if the remainder value is not 11, if the remainder value is not 12, not 13, not 14, not 15, that means the remainder value is a single digit number. That is, the remainder has to be concatenated in such case. So here I will write return get hexadecimal method n by 2 concatenated with REMAINDR. Okay, concatenated with remainder. Close the else part, close the method, close the class. Control K, no syntax error. Control K, no syntax error. Now what is this? Listen. Within this method, okay, within this method, see, within this method, this is the base case. Okay, this is the base case. This is the base case, or you can say terminating case. This is the base case or terminating case, and this else part, okay, this is the recursive case. This is the recursive case. Now, why so many if else are there? Because of that reason only. We cannot put 10, we cannot put 11, we cannot put 12. because this 10, 11, 12, 13, 14, 15 are digits. Okay, and 10 is represented by A, 11 is represented by B, 12 is represented by C, and so on. That is the reason. Now let me check whether my program is working fine or not. Okay, yes, Control K, Alt F4. Right click, main method. Okay, so what was the example here? The example was 3234, and what should be the output? The output should be CA2. Okay, 3234 CA2. 3234 3234. Oh my goodness, oh my goodness, so it is wrong. Okay, so what is the mistake? Let me check the mistake. Where is the mistake? Where is the mistake? Enter integer value n, get hexadecimal n, int remainder is equal to 0. Okay, and then n is less than 16. If it is less than 16, equal to 10, return a, equal to 12, return b, equal to 13, 14, 15, or else return that value of n. Now remainder is n modulus 16. Okay, n modulus 16 remainder. Oh, here I have written divided by 2. Here I have written divided by 2. Okay, this is the mistake. This is the mistake. So here I need to divide it by 16. In the rough work also I have divided it by 2. The rough work also. No, here I have divided it by 16. Okay, here I have divided it by 16. Clear, na? So this is wrong. It is not divided by 2. It should be divided by 16. Okay, so this is wrong. Huh? It will not be divided by 2. Okay, this is wrong. It should be n divided by 16. Now let me change it, n by 16, 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 and here n by 16. Control K, no syntax error, Alt F4, right click, main method. Okay, yes. So what is the example? 3234. Okay, and the output should be CA2. 3234. Okay, let me give 3234, 3234 BA2. But here we are getting CA2, 10, 11, 12, ABC, CA2. It should come CA2. Now what is the mistake now? What is the mistake? If it is 10, A. If it is 11, B, C, D, E, F, n by 16, and then remainder value. If it here, if n is equal to 10, here I have forgotten to write 11. So let me write here. It is 11. Okay, it is 12. It is 13, and this is 14. Okay, and here let me copy this. Control C, Control V, 15, return capital F. Control K, no syntax error, enter. See, enter in digit 3234. Okay, see, CA2. Now the output is correct. See, CA2. The hexadecimal equivalent of 3234 is CA2. Clear, na? CA2. Clear? Now let me check with one more example. Suppose if I will give what? 65248. 65248. The output is FEE0. FEE0. Now let me check whether this is working properly or not. Yes, listen. Now let me convert and check 65248. Okay, divided by 16. 16 2s are 32, 16 4s are 64. Okay, 16 4s are 64. So it is 1, 1, 2. So it is less than 16. So 124, we will take 124. So here I will have to put 10, right? So 124 divided by 16. So 16 sevens are 112. Okay. So 4 minus 2, 2, 2 minus 1, 1, 12. Okay. So 120. So 7 here, 7. Now 128. Okay. 128, 16. So 16 eights are 128. Okay. So 16 eights are 128. Now what is the remainder? Remainder is 0. Now 16. 16 twos are 32. 32. 40 minus 32, it is 8. 87. 87. 16 fives are 80. And 78. 78. 16 fours are 64. So 78 minus 64, it is 8 minus 4. 4. 7 minus 6, 1. 14. 14 is the remainder. Okay. Now 16. 16 ones are 16. Okay. 94. 94. So 16 fives are 80. Again 14 is the remainder. Okay, now 15. Since it is less than 16, we need to stop here. Now from bottom to top, if we see, the first digit is 15. Okay, the second digit is 14. The third digit is again 14. And the fourth digit is 0. So in place of 0, I will write 0. In place of 14, see, for A, it is 10. For B, it is 11. For C, it is 12. For D, it is 13. For E, it is 14. And for F, it is 15. Okay, so here E has to be written. Here also E has to be written. And here 15. What is 15? It is F. F double E 0. Okay, see, the output is F double E 0. So the program is working fine. Okay, the program is working fine. Clear? Clear, no? Now listen. Let me give one more number. Now the number is 256. 256. See, the answer is 100. Okay. Now let me check for this also whether it is working fine or not. Listen. It is 256. Okay. Now 16 into 16 are 256, remainder 0. 16 ones are 16, remainder 0. So it is 100. You can see 100. Okay. So the program is working fine. Clear? Clear or not? Clear, no? So take the screenshot of this. Okay. Take the screenshot of this. Okay. Take the screenshot of this. See, by mistake I have written n by 2. It will not be n by 2. It will be n by 16. Okay. It will be n by 16. Then take the screenshot of this and take the screenshot of this. Okay. So this is the program. Clear? Take the screenshot of main method. Clear? Now take the screenshot of get hexadecimal method. Get hexadecimal method. Okay. So thank you so much. Bye bye. Take care.